thank you very much, everybody, for attending today's. And my name is Ashraf. I would like to give a quick introduction about my company, Madsen Controls and Engineering. Madsen has been in the industry from 1963. We've been one of the earliest Woodward channel partners in the region. We started as an office in St. John's to help marine industry, and we've been growing and growing and growing over the years. By 1990, we opened our first office in Halifax. 2011, we acquired Toronto and Montreal channel partner there. And by 2018, we acquired the West region, and we have an office right now in Edmonton. So we cover from east to west. So if you have a hydro governor or hydro turbine that is in British Columbia, we also can support and service them. As Madsen, we are divided into 3 different branches. We are divided into mechanical governor and repair service. So if you have a mechanical governor that require an overhaul, repair, you can send it back to us. We can do the testing in our facility here in East or in our facility in the West, depending upon which is nearer to your facility. Or if you have an issue with your mechanical governor at your site and you require an expertise to come to your site and do some repair. And as I can see from the result of the poll, you are having some difficulties to acquire some of these expertise. We can definitely help you with that. We also have in-house capability to develop our own hydro turbine control solution. And today we're going to talk about one of the in-house solutions that we provided for our customer to help them if they are looking for an upgrading from their old mechanical governor that they cannot find spare parts for it to electromechanical governors that they can easily find spare parts in today's world. And then last but not least, a power management solution. So we are a Basler rep also. So if you are looking for an AVR or you are looking for a protection relay for your generator, we also have the expertise in-house to provide the complete solution. So if you are looking from the speed sensors up to the actuation, up to the controller, we can definitely help you with that. So our agenda today is divided into 4 parts. At the beginning, we're going to talk about the development of a hydro turbine governor. Since we are Woodward, and Woodward was one of the first governors in the world. So we're going to talk a little bit about the history. And I believe some of you guys have some of the old hydro governors, mechanical governors that have been working for 100 years now, and you're still maintaining them and you're still working with them. And I believe we have a very long history, and I would like to give a quick introduction about that history to show you where we are right now and where we were. And then we're going to go with the standard and specification that govern the selection of a hydro turbine governor. Throughout the years, the specs and the standards kept growing and growing and growing. And the design that was designed based on specification was very old back in the 1910. I believe by 2020, the standards have been changed. And I'm going to give in touch about how these standard has changed and what are the new requirements that the IESO requires from us, so that when we design our hydro governors, we should maintain this, or we should satisfy these requirements. Then I will talk about one of our latest hydro turbine platform and how it's integrated with the whole plant. And then if we have time at the end of the presentation, I will go through one of the hands-on training and quick overview about one of our hydro governors, which is the 5001. To start, our story started by 1870 with Amos Woodward, who was one of the first people around the world to design or patent a mechanical compensating water wheel governor. It was based on water wheel, and it was very simple, based on as the speed of the turbine, or at that time was the water wheel changes, the weights will move to the left and the right, and then you can use it to maintain the speed of your engine or the speed of your turbine at this time. And to show how we were pioneering this industry, the first hydro turbine or the first hydro dam was built by 1882. So we are 12 years before that, where we developed our first governor. So we were ready when the first hydro dam was built, so that we can submit our solution, and we've been using that solution, and many of our customers has been using our solution from 1882 till today. So our first commercial-based solution that was used was the gate shaft, and I think till today, we still have some of our customers are still using these gate shaft. It started in 1910 and stopped around 1960 or 1965, I believe. And some of our customers are still using them. They are very simple to use, they are easy, and they don't require a lot of maintenance in them. But as time grows, these mechanical governors went obsolete, and some of the components are harder to get, but we still maintain them. So if customer has any issue with their gate shaft governors, we still provide services for them. So if any of you guys still have these old governors and would require any help or support or training, we still maintain them and we still service them. By 1938, we come up with mechanical actuator governor, which contained more options like generator air breaker, it's contained cylinder pressure, it's contained the governor system oil pressure. It's again, same concept, but it was designed with more features and more options to allow the customer to have brake control and so on and so forth. By 1956, we improve our design. Now we came up with a cabinet actuator, so you can increase the speed, decrease the speed. You can able to control a little bit the frequency, and we come up with the concept of the dashpot that adds an extra droop or compensating droop or controlling the turbine during the startup and the shutdown, which was a big step at that time in 1956. Then when the analog controllers comes in by 1970, we start to integrate the analog controllers in the governors itself. So we start to see mix between a mechanical governor and electrical governor by 1970. So this was one of the first analog governors at that time. We started to have digital speed sensors. We started to have servo motors. Then the microprocessor-based application came into place. So we created the 505H by 1987. Until today, I still see this 505H in the plants running, and many of our customers are happy with their performance, and it's been in the industry from 1987 till today with lots of success in them. By 1992, we had started to have the microcontroller as a standalone device with handheld programmer, so that you have some sort of a security, so that only the people who understand the programming can do the programming, not like the old 505H where people can use the handheld or the display pod at that time to do the configuration. So it was a big achievement at that time, and customer loved them. And again, they are still in some of the plants that we've been working with them. Recently, we just upgraded 3 of them from the 700H to the latest version, which is the 23100H. So we are updating them, we are maintaining the logic, and many of our customers are still happy with these old controllers. By 1992, the TMR concept started to appear. So people wanted triple module redundancy. So we started first with the Netcon 5000 series. Then we have the Micronet, which is introduced by 1990. And now we have Micronet TMR, Micronet Plus. So again, we have these solutions still in the plant, and some of our customers have them. Today, we're going to focus on the 2019 platforms, which is the 5001. The beauty about the 5001 is that it's designed for achieving 2 different important questions that many of our customers came up with. They needed a built-in HMI for their controller, so not like the old display, which is 2-line display. No, now it is a very fancy HMI where you can see the parameters, where you can manipulate your parameters, you can do your tuning. Plus, if you would like to have a remote monitoring support, so it comes with the Ethernet port and cybersecurity. So if customers are looking for a way so that someone from our office or someone remotely from a different from their office, and they would like to remote monitor the unit itself, the unit comes with built-in capability for remote monitoring of their units. And we're going to go deeper inside these details as we progress in the presentation. So yes, we are good to go with the first part of the presentation. So we talked about the development. Now we're going to go through the standards and the specification that led to today's discussion. Now, the biggest or the independent electrical system operator, IESO, which work at the heart of Ontario Power System. The IESO implement controls to ensure that we have a continual, reliable grid, and they come up with the standards and specification that governs today's design for hydro governors, or for governors, electrical or mechanical, whatsoever. So according to the standards, if your turbine is used for as an independent generator that provides the grid with the frequency, you need to maintain a frequency range between 60.2 and 59.8. This is the range that is acceptable for the standards, so that you can maintain the frequency, or you can call yourself as independent generator, or you can use yourself as independent. And ISO has been implementing these and going to the plants, and I've personally worked with one of them, so that we go to the plant and we do some testing to make sure that we are maintaining the frequency, or if you are using one of your turbine as a droop control or do droop control, ISO wants to make sure that if for any reason there was a change in the frequency, how quick enough your governor will recover and what error comes up out of that. So ISO are looking for two things. If you are independent, you need to maintain this frequency, or if you are if you lose, or for any reason there was fluctuation within the frequency of the grid, that you recover quickly and your controller can accept or can take the load, and within, I believe, 10 seconds, for any 10% change. So for any sustainable 10% change, you can accept, or the governor would take the load and become stable again. So that's where our standards today are requiring. And we've been with the old mechanical governors that been designed back in 1910. Sometimes these requirements are harder to achieve, and it requires from us, you might need to upgrade a little bit, or you might need to add more components, dashpots, or more devices, so that you can achieve the requirements of IESO. And we can work with the customers toward achieving this, so that they can pass their test, so on and so forth. To understand how the mechanical governor works, we have to understand the standard that govern the design itself. So one of these standards is the NEMA standards, and they classify the governors into A, B, and C, and D category. Usually the mechanical governors are the class A, and that's because of the nature of the mechanical governor. So class A means that whenever there is a change in the speed, whenever you have any change in the speed, and you're required to reach to the rated speed. So if you have a governor that you are trying to achieve a rated speed, how much percentage or maximum speed regulation percent you have. So this is your error, basically. If you imagine that this is the error in the speed changes, and it's for a mechanical governor, it's around 10%. For an electrical governor, or NEMA D, which we call it NEMA D, most of the electronic governors, like the one that we talked about, the 5000 and H, are within 0.5%. So this is the percentage error that being accepted from your rated speed. And then the maximum rise, so we define the maximum rise percentage is that when you lose the load. So for unknown reason, you were at 100% of the load, and then you lost the load. How much speed rise would be accepted by NEMA A? So you can get up to 13% if you have a NEMA A governor, but if you have again, electrical governor, is acceptable up to 7%. So that's when we design an mechanical or electronic governor, we work with these standards, which is NEMA A or NEMA D. And you might seen them in the newest governors or newest electrical governors. You can see always we are working with NEMA D. You can see them in some of the mechanical governors. It depends how old the governor is, if they are predate the standards or not, but that's how the reality of the standard it is. And to be honest, these standards were driven also from other applications like steam turbines application and gas turbine application. So these standards also help, like it came from so many requirements, not only from the hydro turbine world. Again, when we talk about the overspeed, how much the trip overspeed for NEMA A, it's allowed up to 15%. For NEMA D kind of governors, it's allowed up to 10%. So these are the standards that when we design a controller, we need to make sure that we achieve these values. Otherwise, the controller will not meet the standards of NEMA or meet the IESO, which is the Ontario Power Generation Standards. And going from there, I would like to give a quick introduction about one of our latest solution, which is the hydro turbine, which is we call it Flex 500 or 5001. And as we discussed, the standards today require that you have a controller with cybersecurity capabilities so that when you do remote monitoring, you don't worry about hacks and so on and so forth. So all our controllers comes with built-in features. If you do a remote monitoring, you have some sort of a cybersecurity in them. And it comes also like your cell phone with ability to connect to other devices. So it has the Modbus capability to connect to the D-Slicks, to the AVR, which is the DEX 250, to connect to one of our CPC2 or various stroke. We are designing our controllers to be easy plug-in this kind of controller where you don't need any more configuration. It's just a simple device with simple questions. Do you have a D-Slick 2 or not, which is used for synchronization? Do you have a DEX 250 or not, so that you can connect to the DEX 250 and get the Modbus addresses and get the information about the DEX 250 while you are running your Flex 500. If you have, okay, CPC2 doesn't come with lots of diagnostic, but if you have one of our various stroke devices that our activation system, it's connected to it, so it's built-in, has a built-in features that connects to the various stroke. And then it can be connected to either a Kaplan turbine or a Francis turbine. All you have to do inside the configuration, which comes out of the shelf, to define what type of turbine you are looking at, if you are looking at a Kaplan or a Francis, and boom, you are good to go. So we provide a complete integrated solution. So we provide the governor, we provide the synchronization and the load control through the D-Slick. And then we provide the AVR, which is the excitation for the generator. And then if you would like to control the utility breaker or the main breaker, we can also provide you with an M-Slick. And all our solution comes in with the capability to connect through Modbus to your DCS or your plant PC. It's a very out of the box solution. You don't have to do lots of configuration. The configuration is being configured in the unit. All you have to do is to define the parameters of your turbine itself. And the solution has been developed here in Canada based on the Woodward governor solution that has been there from 1910 basically. And this is based on your existing 505H. So if you have an existing 505H or if you have an existing 700H, the solution is backward compatible, so you will not find any issue with them. In fact, you will find more options that allows you, if you're looking for load sharing capability between units itself, then you can have that load sharing capability. As you can see from here, the unit itself share the information together so that you can do the load sharing capability within the units itself. So it's an interesting platform. I really like it. I've seen customers when they see the HMI capability of the unit itself, and hopefully today, if times help us, I will go through that and I can show you how excellent unit it is, how the unit itself will help you with solving many of your problems at the plant. So we talked about the HMI capability. The unit also comes with a turbine operation and logs, and I will show you that. Real-time trending. It has an Ethernet, so we have 3 Ethernet ports in it, and the 4th one used for service port. And then we have the ability, if you have more number of IOs than the actual unit, we can add to it what we call a linked net module. We talked about the ability to connect to actuator and a D-Slick, so the unit comes with built-in capability to connect your D-Slick and your actuator. And then if you would like to have a remote access to the unit, we have a software called Remote View where you can see the unit itself and see all the parameters so that you can control it as if you are in front of the unit itself. And then we have some service tools that help you with data loading and diagnostic. So for example, if you see an issue there in the plant and you would like to do some further diagnostic, we have a service tool which is not an operation thing. It's more for diagnostic capability. So these are the remote view software. So as you can see, the remote view gives you the same layout like the 5001. So it comes with all the HMI, and then you can use your keyboard as if they are the keyboard in here to control the HMI itself. It comes also with vibration sensor kit. So if you have if you would like to monitor the vibration of the unit itself, it can allow you to monitor that. So you can buy the vibration sensor kit connected to the unit itself, and you can monitor the vibration. This is how the unit looks like. As you can see from the front side, it's very tiny. It's 3.3 inch. It comes with Phoenix contact pluggable terminal block. So all you have to do is remove the terminal block, put your wire, and then you put your Phoenix contact, which I found many of our customers like that because it eases up the installation time and save a lot of time when we do some installation. So if you have one of our old 505H, using this unit, it will not take you more than 4 hours or 6 hours to do the changes, because again, the number of IOs is identical. Actually, we have more number of IOs in this unit than the old IOs, and the easiness in changing the Phoenix contact terminal blocks allow us to do that wiring changes in a quick time. To access the unit, you have 3 different user levels. We have an operator, a service, or a configure user, and each one comes with a password enabled in it. So this adds an extra layer of protection. Not anyone can access the unit and can do a configuration change. It's only the intended user who have the access level can do the changes that is required. So we added the user level function to the 5001. You can do some calibration. So if you're looking to actuating the valve while the turbine is off, or you would like to start and open your gates, we have the capability to do in-house calibration using the unit itself. All you have to do is you need to have the user level that allow you to do that, either the service or configure user, and then you take the unit out from operation to calibration mode. And then you can, the unit will not be able to run. It give you the ability to force the value so that you can open the gate and you can close the gate. Or you can go in the configuration mode, and in this condition, the unit will not send any signal, and you can configure the unit. And usually one of your high-level engineers or one of us can come in and do the configuration for the unit. And the configuration is very simple. It's simple questions, and I will be showing that while we go through it. We added a very interesting feature, which is the proximity sensors. So as we know, the hydro turbines run at very low RPM. You may talk about 10, 20, 30 RPM, 300, maximum up to 300, 400 RPMs. With the MPU usually doesn't provide accuracy at very low RPM, but with proximity sensors that been added to the 5001, you can able to go at very, very low RPM. It can detect 10, 20 RPM or 5 RPM, 3 RPM, because the proximity sensors send power to the unit itself. It doesn't depend upon that the unit is running, so that it can generate enough electromagnetic forces so that you can detect the speed, and then you can have it. With the MPU, we send power to the sensors itself, so we can use it to measure a very low RPM, 1, 2, 3 RPM, and that's the beauty of the new units. It comes with the proximity sensor capability. We talked about the trending, so now you can, while you are next to your unit, you can have the trend. You don't have to go far away, or while you are next to the unit, if you would like to trend the unit, you can see the custom trends in here, and you can do whatever trend. You can select whatever range. You can change all the parameters, so that if you would like to do some maintenance while you are next to the unit, you can still do that and see the trends of the unit itself. It comes with timestamp for alarms and trips, so we pre-configure it. So every single alarm that generator, it comes with the timestamp. It tells you when the alarm happened at what time. And if you would like to synchronize your 5001 with your PLC, we have an SNTP server built inside the unit itself. So the unit itself can connect your SNTP server and synchronize the time, so that if a trip happens within the plant, the time on the unit, the 5001 is similar to the time on the PLC, and then you can help you with the diagnostic. Which caused the trip? Is it actually the governor itself is the one who's causing the trip, or something else? Because all the trips and alarms come synchronized together, so you can, using the timestamp, you can able to define, okay, where the problem comes from, and that help with the diagnostic if you have a bigger issue in the plant. We talked about it comes with a built-in capability, so it can connect to your power management solution. So we talked about it can connect to your D-Slick or your BASDAR AVR or your actuator interface. So we have an example here where you can see I can connect to my vari-stroke and I can see what problem within my vari-stroke. So it, and the alarms and the fault conditions. So again, it's like your iPhone. When your iPhone nowadays, all the iPhone comes with a camera, with everything in it built inside the unit itself. Same thing with our new philosophy with the 5001, that all the different parameters that's connected to the unit, you have the ability to access them and see that. And then we have a very nice feature, we call it turbine operation value. You could define here how many times you started your turbine. How much is the total trips? How many of these trips under 25% of the load are? How many of these trips under 75% of the load? This is a very unique feature, because if you know that you have a lot of trips under 25% of the load, this means that you might be having a sticking within the actuation system or within the gate. There might be an issue with that. And you know the condition that led. So sometimes you have a problem that is happening a lot, but you don't know at what condition of the machine itself where these conditions happen. So by getting these two features, which is the 25 and the 75%, you can define that. Again, we have the overspeed trips, so it defines how many overspeed trips, how many was the running of the turbine. So if you have 3 or 4 or 5, depending upon how many hydro turbines, you can define by using this feature how many of these turbines run at 75% of the load. So you know which turbine is more loaded, and then maybe you can take the decision at that time, okay, I've run this turbine for a very long time and I loaded this turbine for a very long time. It's time to switch from this turbine to the other one because the other one has not been used for a long time, or the load wasn't so much for a long time. So this runtime feature is an interesting feature if you are looking so that all your turbines been used in the same way or in the same number of hours, basically. And then it comes with what we call a fast data log. Sometimes I'm an operator working in the middle of the night. I've seen a phenomena that happens in front of me, and I would like to store it so that in the morning when the service team comes in or someone else comes in, I can explain it to him and I can show him the trends. So we have a feature there inside the Flex 500 where a customer can, or where the operator can press a button, and then it will store all the inputs and the output that comes to the Flex 500, so that if you would like tomorrow morning to do some diagnostic, or you would like to send it to us to do some diagnostic, we could see what are the parameters, what are the inputs and what are the output that happens to the Flex 500, and we can log it and we can maintain that in our system. So you can come back and say to us, okay, please take a look on that log and see what's going on. So that's a very nice feature that helps the operator to do some maintenance. Also, if there is a trip condition that happened within the unit itself, the unit has the capability so that it stores the data 2 or 3 minutes before the phenomena and 3 or 7 minutes after the phenomena, depending how the unit is being configured. But you can define this time so that you can able to test it, or you can able to know what happened to your turbine during the trip condition. So these all are features available in the new 5001. So I can see here I still have 10 minutes. So I will be taking a quick look at our 5001. So this is the new unit, which we call it the 5001. It comes with, as you can see, as an HMI capability. The beauty about this software, the remote software, it doesn't require a fancy PC. It doesn't require anything. All it needs is a Microsoft Windows and a PC. And all what you need, you don't even need to define the size. You can come here and change the size of the unit itself based on how big is your screen or how small is your screen. So you don't have to worry about how the screen size should be, nothing. And then it comes with the capability, if you would like to see only the HMI without the buttons in it, you can define that, so you can have the HMI only, or if you would like to see a simpler viewer from the unit itself, you can also define that and you can see it. So it's a very nice HMI, like you don't have to worry about a lot of setup when you want to do that remote diagnostic capability of the unit itself. And then if you would like to see how easy to configure the unit, you can go to what we call the configuration mode. So I have to configure, I cannot be as an operator to go to the configuration mode. So I have to log in. I put my accreditation here, and then I can log into the unit itself. And I can define myself, I can put myself in configuration mode, and then I can go here and configure the units. To configure the unit, it is simple as defining what type of turbine you have. Like, for example, you here, I would ask you if you have a Francis or a Kaplan turbine. It's simple as that. It's very easy questions, as you can see. Do you want to reset the clear trips relay, or you want the user to have the ability to have to press it? So this can automatically reset it or not automatically reset it. Do you want to allow remote control or not? So if you don't want your user to come in and do any remote control, or if you want them just for monitoring purposes, you can disable that. And then you can define the speed set points. Again, what's the overspeed value? What is the nominal speed value? And all that can be configured within the unit itself. And then if you did any configuration error, the unit has the capability to detect the error, and you will get here an error message telling you that I have an error within the unit itself. And as you can see, every single parameter is just a simple questions. You don't have to have a programming level to configure the unit. All you have to understand is your turbine and what are the inputs of the turbine and what are the outputs, so that you can configure your own unit and you can do all your changes. And then, as we discussed before, it has the capability to connect to other devices, like the LinkNet module, which we talked about it. That LinkNet module is an extra IOs, so that you can add an extra IOs to your units if the 5001 IOs were not enough. Here is the capability to connect to a DSLIC, which is a digital synchronizer. We also have the capability to connect to other actuation systems, so the variostroke can be connected to it. Protection relays, different protection relay with MFR 300. So all these features are already configured, built in. All you have to do is just to enable them or disable them. It doesn't make a difference if you enable a feature or doesn't disable. So the unit is flexible enough so that if you disable some of the features, does not affect the whole plant. You can use them as much as you want. If you want to use the 100% feature, you can. If you want to use 90% of the feature, you can. You don't have to use a certain feature alone. And then when it comes to the overview and the HMI, you can see here how easy it is. You can see the speed set points, you can see the active power, you can see the gate position, you can see the level changes, so you can measure the level. Again, if the parameter is not available there, or if it's not connected, the value doesn't affect. You just have the value there, but it's not gonna make any issue for you. Again, how you configure your analog inputs, all this affects the relationship and the parameters that appears in front of you. We can go also into the service mode, and then here we can define our custom trends, and then you can come here into the settings itself, and you can define, okay, I want to see the gate position. I define the gate position. I define what is the minimum of the gate position, 0 to 100, and then I define the width of the line itself, so that if I want to see that graphics, how easy it is to see the graphics, and so on and so forth. You can also have the capability to do what we call an operation log. We talked about the number of starts, the total trips, how the turbine trips. You can also have there a maintenance alarm. So a service user can put here a maintenance alarm and define, okay, if the turbine runs for 15,000 hours, for 4,500 hours or 10,000 hours, and a maintenance alarm would appear for the operator, so that it knows, okay, it's time for me to do some maintenance on the unit itself, or to call the maintenance team to do some maintenance there. So this is also a nice feature. Like in your car right now, you have like an alarm that comes in. It's time for you to do your maintenance. Now you have that in your 5001. Data logging capability. Again, if, as I said to you, if an operator see an issue and he would like to do some sort of a data log or store the data that comes to the unit, all he has to do is to come here and hit the start data log, and all the data that is related to the turbine at that time will be stored. And then after the phenomena is ended, he can hit stop data log. So all the data or all the phenomena has been stored inside your PC, so that you can come in, plug in, and take that data and do some more diagnostic to define what the reason that happened at that time. Again, we talked about the capabilities, so that if you would like to do some manual opening of the gate itself, so if you want to test your gate, and you can come here, you hit enable, and then you can test your gate. You can raise and lower, and you can test through the rates. By enabling it, you can do that, but you need to be in the calibration mode, not in the operation mode right now. So once you hit the calibration mode, you will start to see the extra functions coming in. And I can also, what you can also do is you can see the startup curve. So in here, you can see how the turbines start, and you can monitor the vibration. So if you have a vibration signal coming to the unit, or you bought the vibration sensors that comes into the unit, you can also monitor here the vibration, so you can see what is the alarm. You can generate an alarm too. We call it a trip. You can, if you want to configure it so that it trips the unit, yes, you can trip the unit based on these alarms, but most of our customers only use it so that it generates an alarm for them, and it leave it up to the user if you want to trip it or not. And then if there is an issue with the vibration signal, you can get a fault here and tell you that I have an issue with my vibration signal. Controllers. So as you can see here, you can do an overspeed test. So if the user would like to do an overspeed test, so that it tests that the unit is how the unit will behave during the overspeed, yes, you can run that through the test through the unit itself in a very safe manner, because it will not reach above the 120% or above a certain value. So we have a test limit for the unit itself. So if the test limit is configured to be, here is too much 160, maybe you can put it at 120%. So you run the test, you start your turbine, and you know that it should be tripping at 110% of the rated speed, or 120%, or even 140% of the rated speed. We configure the unit itself so that once you reach to the 140%, it will stop your turbine in a very safe manner. And it's all done automatically without user intervention, so that it protects the units. If the trip failed, it will generate a trip failure, and without actually having to take the turbine above its design value for going to that overspeed testing value. Yeah, we talked about the manual maintenance, and oh yeah. I think that's the end of my presentation. If someone has any question, we can open the question right now.